can see that the manipulator is controlled by 3 specific servos that's going to go in like arrangement and stuff, and it's going to control the entire thing. Now, that's it for the basically the theory of the entire manipulator, and now we're moving. Oh, whoops. Now we're moving to the code. So this is the entire code I write, thanks to a robot called ChatGPT. Yeah, so this code was written by me and someone else, but the technically include servo H. That means that it's gonna include a servo, right? Servo is like that thing, so it's gonna include it. Constant integer, pot 1, min 0, and then max is 1023, which means that this is a constant integer. Pot 1 underscore min, pot 1 underscore max is a constant integer, which is going to make like 0, and then there's this 123, which I think is the max. I forgot about this, so I just wrote a number that on top of my head, and it still works, so whatever, right? What like all engineers say, if it works, don't change it. So these are just basically 3. This is the version 2 and version 3, which is the servo over there. This is 1, 2, and 3. Now, this is all complete, right? We've already explained that. What is constant integer servo 1? Is center. That means that this is probably like the center of it, because it says center. So yeah, this is another thing. So it's like gonna go back and stuff, I think. And then integer servo 1 underscore pin. That means like an integer. This is going to equals to 9. So that means like the servo pin equals 9. And then this is for number 2 and number 3. Now this is servo, which means we're going to name the thing we have before. We included a servo. So we put servo and we name it servo 1, servo 2, and servo 3. So we can like use the code easier instead of having to write this and like jumble it up or whatever. But yeah, so in void setup is like we're gonna set up everything, right? So the void loop is going to run well, and in void setup we have pin mode. Pin mode is like setting the pin's mode. It's literally in the name. So like it's gonna set the pin on what it's gonna do. For analog 0, it's going to give an output. So that way it's going to give an electric current that's going to say, hey, you need to go output, right? And it's happening for A1 and A5 too. And for pin mode, this is another pin mode, which is going to set the pins. For servo 1 dash pin is output. And since servo 1 dash underscore pin is equals to 9, so it means that this could just be deleted and could be changed to 9 and it would still work the same, which is also an output. And this is 2 and 3. This is this one. Servo 1 is the thing we did over here. We're going to like name the servo, right? So we could understand it easier. So we attach this to servo pin, which this one is output and it's 9. So that means it's gonna be like on 9 and it's going to go on output. So we're gonna set up everything here. Now for a loop, this is where things get interesting. Well, for this one, there's an integer, another integer, which is pot 1 underscore val. We only had pot 1 underscore min and max, which is already set above. But this one is going to analog read, which is like we're going to see and analyze what is happening at the analog, which is analog 0. And same goes for 2 and 3. And then this one is more complicated, but I'm gonna explain it so it's gonna be simple. Now we have integer servo 1 underscore post, which is another integer we're going to write. And this equals to map, which is I haven't practiced this one. Yeah, I haven't practiced this one. But map, I think, is something like we're going to like compile everything up together. So pot 1 underscore val, which is this, we read analog 0, right? So this is gonna read the pot 1 underscore min, which is 0, pot 1 underscore max, which is 1023, and then is 2 of this. So map is going to put this one as these 2 variables, and then gonna put it to 2 variables. So 1023 is going to be the same with 180.
Sorry,
so
this using number, but this variable. What's the difference?
What the difference? Well, the difference is that we are using this one as a word because the word we've already changed it to a number,
Okay.
so it's technically just the same thing.
Okay.
It's just the same thing. Now, servo 1, right? We already read servo 1. This is attached to this pin, right? But servo 1 is just the name of the other servo, which is right, which is going to be this one. So whatever the servo do is going to be with this. So it's going to just repeat. And this is for 2 and this is for 3. And that's it.
Okay.
Now for the demonstration,
Okay.
the part we're all waiting for, the end product. This is a montage of, but this is in real life, so I can't do that right now. And so we're going to. Hopefully it still works under the condition of this thing. Yeah, it still works. Okay, so this one, I think it moves this one. Oh no, it moves this one. There you go.
Okay.
I need to check the controls. This one moves this one. There you go. And this one moves this one. Okay, it still works. Now I'm gonna control it. This is the fun part, right, guys? So we're gonna go down here. Okay. Okay. A little bit to the left. There you go. Clamp it down. Oh, Malcolm. Lift it up.
Okay.
We could turn it anywhere we want. Let's throw it to you guys. Wait, ready?
All right.
This is let go, right? No, this is let go. Oh, we let go accidentally. Let's play it for a while. Okay, we're gonna throw it. Oh, we can't throw it. It's not strong enough, but you get the point. It works. Okay, I guess that's the entire manipulator. What do you want me to do it again? I was about to like make it switchable, but I was too lazy to do that since I don't have another motor. Like I could like change it to like a knife or like a hammer or something like that, but yeah, I guess this is the manipulator.
Okay.
Thanks for watching.
Done. Yeah.